So what we've done in this section 5 of the Measuring Pi, Squaring Phi website is create an Excel spreadsheet listing all the circles that I used in the proof and the square and their attributes. Here's the circles attribute: it's its circumference, its diameter, its radius, and area, and the pi, of course, that we used and we also derived 3.144605511. For the square, we have the side, the diagonal, perimeter, and the area. So we ask ourselves, once we square the circumference of the circle and to the perimeter of the square, and I did it for all of the circles in the various proofs listed here, are there any other constants for the attributes of the circle relative to the square? And what we discovered was that yes, indeed, there are. For example, if we move over to the center portion of the spreadsheet, we can see that once we square the circle to the circumference to the perimeter, and we also, as you saw, physically measured and also solved for pi, and pi is always 4 over the square root of the golden ratio. We asked a question, what about the diameter of the squared circle divided by the side of the square, the squared square? And in every case, the answer was, it's a constant of the square root of the golden ratio for every circle you can see that we did here. And continuing along that line, we asked the question, move it over here to 4 more ratios. What about the diameter of the squared circle divided by the diagonal of the squared square? In every case, it was the square root of the golden ratio divided by the square root of 2. In every single case, the attributes ended up being the square root of phi divided by the square root of 2. What about the area of the squared circle divided by the area of the squared square? It ends up being, amazingly, square root of phi, again, for every circle. That's the relationship of those attributes. Well, let's take it further. What about the surface area of the squared circle divided by the surface area of the squared square, which means we're doing a comparison of the surface area of a sphere to the surface area of the cube. And that ends up being, as you can see, 2/3 the square root of phi in each case. 2/3 the square root of phi in every equation, every computation, every ratio. Let's take the last one. Is what's the volume of the squared circle, which is another sphere, the volume of the sphere we want, divided by the volume of the squared, which is a cube. That's 2/3 times phi. In every case, 2/3 times phi. Surface area was 2/3 the square root of phi. The volume inside the circle and the square is 2/3 phi. So what we really discovered here is that besides pi as universal constant, we discovered 5 more universal constants. Once you square the circumference of a circle to the perimeter of a square and list the attributes of the various of the circles and the squares involved, you get more universal constants. And the key thing to note is that they're all related to the phenomenon of the golden ratio. So pi is just one of many in this phenomenon, and that is why one needs to take that approach instead of other approaches like the Archimedes calculus polygon limit approach, or some other people's approaches that don't involve squaring of the circle to the square, squaring of the circle to the perimeter of the square.